Okay, it's very nice to have Zhou here with us to basically teach us about natural language processing from a computer science perspective, which I think we are all very eager to learn. Zhou is a good friend of mine. We got to know each other actually in graduate school in a book club actually. And Zhou led some of the most memorable discussions of actually literature. I don't think I need much introduction because Zhou is actually a very prestigious scholar in natural language processing, as some of you guys may know. She actually just got AWS Machine Learning Research Award. Is that correct?
Yes, absolutely.
And many other prestigious prizes, as you can see from her website, like Amazon Alexa Prize and Forbes 30 under 30 in science. So it's quite an honor to have her here, and let's just jump into it, I suppose.
Yeah, thanks, Wei Jiao, for inviting me. So today I'm not gonna represent the entire NLP community. So I'm just only gonna teach you a little bit of how to build machines that can enable natural communication with humans to help them complete tasks, provide companionships, and so on. Specifically, we're talk about a line of my work on persuasive conversational systems. So I just moved to Columbia University from UC Davis. First of all, let's do some basic introductions of what is a conversational system or a dialogue system, or sometimes people call it personal intelligence agents or so on. So usually when we talk about conversational systems, there are two types of conversational systems. One, it has a task that drives the conversation, and the other doesn't. So the goal is to have social connections. So we usually use various different frameworks to model these two types of systems differently. So task-oriented systems are usually users and systems have an aligned goal, which means I want to book a flight and the system know exactly I want to book the flight. So usually the capability of the system and the user's intent are well aligned. So tasks are varies from domain to domain, such as booking a flight, booking a restaurant, getting bus information. While social chatbots is mostly the bot can talk to anyone about anything at any time. So this is a video of my student, Michelle, talking to our Alexa Prize winning chatbot.
Our dog is named Bonsai, so he came with that name. We think it fits him pretty well.
That is a great name for a dog.
Yeah, he's kind of short, like a bonsai tree, so it works.
Tell me, how long have you had Bonsai?
We've had him for a little over a year now, yeah.
Oh, you must be great friends.
Yeah, we are.
So this is a small snippet. So the chatbot is able to identify a mutual interested topic, which is a pet, and then he's able to remember the name of the dog and trying to express some emotion towards the dog, so on. So these are some of the interesting traits of our chatbot that helped us to win the prize.
Our dog is...
So it was really nice to win the 2018 Amazon Social Bot. So we're going to participate into another challenge this year again, but not particularly on social bot, but on task-oriented system on how to do some of the tasks such as cooking, self-help, such as fixing toilets. So it was really interesting to actually win a $500,000 prize. My students are really happy. So there are around 8 or 7 of them. They're actually splitting $500,000 among themselves, which is everybody got a new car in the end of the day. So the most interesting part is by participating in this challenge, we're able to actually reach millions of the users because the Alexa chatbot that we built is deployed on Amazon Alexa right now. So if you say, Alexa, let's chat, and it will open up our scope. So we got a lot of interesting feedback. So there were a little girl saying that, Alexa is now my family. I like to talk to her every day before I go to sleep. So there are especially a lot of kids really enjoy talking to Alexa. So they're really looking at Alexa as a companion. So the question is really now we have all the hardware systems. We have millions of Alexa, billions of Alexa maybe type of devices really located in a lot of people's home. So everybody wanted more from Alexa, more functionalities, more things it can do. So the question is really, how can the software go to the level of people's expectation? So today we're going to talk about one type of conversational system that haven't been deployed, but could be very much interesting future work for deploying. So we're talking about persuasive conversational system. In particular, if you look at the background, they're actually mixing task and social. So if you wanted to achieve things such as change people's mind and attitude, having a good social bond and a relationship could be a really important cornerstone. So when we talk about persuasive systems, we're really talking about how to change people's beliefs and behaviors, or even, or on the other side, how to do a simulated settings. So training people to learn how to persuade other people. So there are various tasks under the persuasion big theory in communication. So we're doing tasks such as persuade people to do exercise. With ECSF and Davis, we're having a program to actually recruit participants with type 2 diabetes to monitor their daily steps, and trying to have a chatbot on their phone to talk to them every day to help them resolve difficulties and adapt to individual people's difficulties to persuade them to perform exercise. So during the COVID time, our chatbot, social chatbot, also has a component that persuade people to perform social distancing and so on. So we also have a simulator that trains counselors in suicide counseling. So here, particularly these high-risk tasks such as suicide counseling, we're not deploying the chatbot to be the counselor. We're actually developing a system that acts like a visitor and trying to train the counselor, novice counselor, because originally all the novice counselor has to do role playing with senior counselor who tries to impersonate a visitor. But these senior counselors are really expensive, and they really wanted to actually serve more people. So having a system to perform so these kind of training could vastly reduce the cost of the public service. So of course, this persuasion is really difficult. It's even really difficult for humans. So that's why we see all these kind of bestseller spoke in the airport. They were split into difference beyond reasons. All these kind of interesting anecdotes or theories that in communication. It first started, I guess, persuasion is really in social science, in the social psychology, and then definitely it got picked up by marketing people, and then it even got picked up on various these kind of popular science. So it's really difficult for human to perform it. Is the robot gonna do as good as a human, or even can do better than an average human? So in order to teach the robot to persuade people, we first need to collect data, and then we need to learn the semantics of the data in order to respond to people correctly. And finally, we're gonna employ strategies adapting to different users in order to improve performances of the chatbots. So data is really a paramount challenge in dialogue system modeling. So we usually model a dialogue system of human-human conversation. So basically you can think we are gonna find a good persuader and trying to imitate what he or she is doing. But the problem is with different users, different people may say different things under the same context. So it's really an exponential growth. If you have more conversational turns, you have more possibilities to cover. So it's impossible to collect all types of possible things that people can say under a domain. So how do we actually collect all these possible data, which we can? So what we can do is just collect a portion of the data and trying to generalize. Another thing is people, for example, John or Mary may have different preferences in conversational settings. When we talked about exercise, Mary may be more happy to do things in the morning, while John may be more happy to do things in the afternoon. So these are kind of different things may change the conversational content overall. So we also want to make sure that we can adapt to individual users. Another challenge in natural language processing in general is how to understand deep semantics. With all the deep learning models, bigger pre-training models, we're doing pretty good in terms of lexical information. But in terms of deep understanding in semantics, we're still a long way to go. So we have seen these kind of horrible news about AI systems all the time. For example, Twitter. So basically, Microsoft released this kind of chatbot called Tay on Twitter. And it says that the chatbot will learn from the interactions it has with users. And the users are really trying to be very creative of saying dirty things. So they're not saying specific dirty words, but given the context, it's very dirty. So without so understanding these kind of deep context requires a lot of common sense, cultural background, which the chatbot does not have, and it adopts words that are these people say and became racist. And there is a lot of other cases happen that it really comes from the lack of deeper understanding. And then finally, strategies, why strategies matter. Sometimes you want to say the same thing in terms of semantics, but the way that you say it really matters to the results. For example, flowers and balloons are much more persuasive than pizza or cardboards when it comes to a marriage proposal. So the same thing applies for various other conditions. So today we're going to talk to you about how do we build a persuasive dialogue system, starting from how to collect a good data set of human-human conversation, and then how do we build these safe systems with limited data, since we're not going to be able to cover a large space. And finally, if we have time, we're going to touch upon how do we design strategies giving users reactions so that we can have more adaptations. So you can think about advertisement is like one round of persuasion. Everybody gets the same. But when you're talking a chatbot, we can make adjustments given your response, which is much more powerful. So first of all, we're going to focus on a specific task called support charities. Basically, we want to persuade people to donate to a charity called Save the Children. Previously, when we collect dialogue data, it's really a pain because in customer service, the real dialogues have a lot of private information. So no companies wanted to release their data to the public. So a lot of times we would go to Amazon Mechanical Turk and ask Mechanical Turkers to role play different tasks. For example, you're gonna be the person who help us book the restaurant. You're gonna be the customer who needs to book a restaurant. Here are some of your constraints. Why don't you two pair up and carry a conversation? So these role-playing tasks usually do well in a collaborate task. But when it comes to a more competitive task, such as persuasion or negotiation, things can go wrong. First of all, there is no real incentive why you need to book that restaurant, right? So, for example, there are a couple of previous data sets that deal no deal is like they tell people A and B that you have conflicting utilities. So if A gets a lamp, which is a product they gave, then B would not get the lamp, and then he will get less benefit. But they're not really tying that to the pay. Craigslist bargaining is people are bargaining on products on Craigslist, but it's also role playing. So it really is, do the people actually perform as they really wanted to participate and try really hard in persuading the other people? So what we try to design is using monetary incentive to elicit a more realistic behavior in persuasion. So we are telling people, if you come to the task, one of them will be randomly assigned as a persuader. So he will receive bonus when the other person decides to donate to the charity. While the other person, when he first come to the task, we just ask him to talk to the other person about a charity. So that nice thing is, when you do Amazon Mechanical Turk task, you get a pay for completing the task. You can also get a bonus by completing the task. So here, we're gonna ask persuaders to tell the persuadee to donate some of that task earning to the charity. So this is the goal. So the persuadee is, of course, as a Mechanical Turker, he came to the platform. Of course, when he completes the task, he wanted to earn all the bonus he can get. So so he's really changing his original idea of, oh, I want to get all the bonus, into maybe I wanted to share some of the bonus to the foundation, Save the Children. So it's actually, there is real money involved in this process. And of course, here we say, if, for example, the persuadee donates to the charity for $1, the persuader is going to gain 20% of that pay. Well, of course, any Turkers wanted to get a little bit more money if he could use, given the fixed time amount he's invested in the task. So now it creates some real incentive for the persuaders and persuadees to, persuader is going to be really using various persuasive strategies to persuade the other person. And persuadee might use various resistance strategies in that. So before the two Turkers come to actually talk, we did a pre-task survey to collect some basic information about themselves, like Big Five personality, moral foundation, and decision style. So this information we wanted to use later to do adaptation in chatbots. And then they were going to pair it up, and then they were going to conduct a conversation. We request them to at least to talk for more than 10 turns in order to exit this, complete the task. And finally, they would decide how much they wanted to donate when they go into another page. And they would say, oh, persuadee wanted to donate $1, and that $1 would directly go to Save the Children. So Turkers are donating real money. So we collected around 1,000 dialogues, and we're able to actually collect around $500 of donation to Save the Children Foundation, which is quite impressive. It's actually beyond our expectation that a lot of people are very willing to contribute to the charities. Another interesting thing is actually some of the persuaders also donated, not only the persuadee donated. So here is an example of persuasive conversations that we collected. So you're probably on a computer right now, so you probably have quite a bit of money yourself. Don't you think you could spare maybe 25 cents for some needy children around the world? And the persuadee is saying, no, thank you. Do you have children yourself? What if your children were in a position these kids are in? Wouldn't you want someone to help them? Where are those children's parents? If only they had a parental support, but in war-torn countries like Syria, their parents are being killed in wars or are fighting for their country. They have no help, and that's why they need your support. Please find it in your heart to just give a little bit tonight. That's all I'm asking. So you can see the persuader is trying very hard, generating these kind of various strategies, while on the other side, persuadee are sort of trying to resist, but still keeping the conversation going. So the idea later is we're going to replace the persuader on the left into a bot and still being able to be very persuasive to collect the money for the charity. Okay. Any questions so far about the experimentation and data collection?
If I may.
Yes.
And so say this is a boring kind of selection problem question, right? But so you mentioned that these End2End people, right, they actually donate quite a bit. But do you have general concern that say like these professional talkers, right, their concern between money and other social objectives may not be representative of the general population that you're interested. Given that a lot of them are taking low-income job with hours to earn money, so on and so forth.
Yeah, I totally agree. So the reason that we use Mechanical Turk is we wanted to get an access to a pool of diverse people. So it's actually much better than just recruit college students.
Yes,
so this is the best thing we can do. But sure, it's not a representative population of the entire population in the US. So we did constrain it into US so we don't have language issues and so on. Yes, we have another hand.
Yeah, I'm asking a question, an experimental question as a non-experimentalist. I was wondering how, so people know that they are watched. I mean, it goes towards this Hawthorne experimenters demand kind of effect. But so, I mean, when you are normally approached in the real world by some of these people who want to get donations, some of their strategies are rather aggressive. I mean, they start off nice, but then given that it's their source of income, they use some strategies which, are pretty tough. And so it's probably unlikely that you will observe them here, these more aggressive strategies on the upper bound. Because people know, okay, there's a certain limit, but I'm watched and recorded, so I'm not going as far as I would in real world. So I'm not sure, because if you assume that in terms of the language they use and the aggressiveness, there's sort of a linear relationship, then that's fine. But if there's a kink, so because now we are all saturated, we are getting asked every second day to donate to something, that you need to do this extra push to elicit people to donate, whether you might miss something by them being known that they are observed.
Yeah, you're right. Definitely, we did do disclosure that the data that we collected is going to use for research later. So they know the data is recorded, and we actually publish the data, but we do remove any sort of sensitive information. So of course, but there are Turkers being a little bit more aggressive that we do see in the data set. But it's not that many. So we do see people say, oh, you're really cold-hearted, using negative words even. But we don't see that many, but most of them are trying really, so when we look at the strategy, they're more like emotional appeal, personal experience, and things like that, instead of harassing people.
Okay, thank you.
Okay. Great, okay, let's move on. So once we have the data, the next thing that we do is to annotate some semantic information on these individual utterances. So we can actually use that to better understand the data, and also use that as the backbone to build our conversational system. So as we said before, this particular task, it has certain task components, and some of them are social components to elicit information about the other person. So using in the social components, we're using a conversational dialogue act mechanism that we designed in our lab for social conversational agents. So we're looking at mostly syntactic information, whether is this an open question? Is it a yes, no question? Because if we know that the user is asking a yes or no question, then we need to know that, oh, we need to reply with a yes or no first. So we're also having some categories like greetings and thank you, because these are, you have a specific template that you normally see in replying that. When people say good morning, you say good morning too. When people say thank you, you say you're welcome. And it's specifically for the task, we wanted to understand intent, or you can think about semantics in terms of, I want to understand if do you agree to donate, or do you disagree to donate? Are you asking me some task information or not? So these intents are so important because I have to answer them correctly, respond to them correctly in order to make it the conversation coherent and people can trust that you can do your thing. So for example, the same conversation, like you're probably on computer right now, so you probably have quite a bit of money. Don't you think you could spare maybe 25 cents? So here is task information on this potentially long question. And it's a request to donate. So basically the intent is, why don't you donate? And you can have various forms of expressing the same intent. But the underlying thing is, can you donate? While when the persuadees say no, thank you, it's an intent called disagree to donate. Do you have children yourself? Now, since that we got a rejection, so people are going like circles, trying to talk about something else in order to avoid the awkwardness. And on the other hand, maybe collect more information from the users in order to personalize your persuasion strategies. So do you have children yourself is considered more social. It's not really direct related to the task. It's a yes, no question. What if your children were in a position these kids are in? Wouldn't you want someone to help them? It's a social question, yes, no question. And the assistant, so the other person didn't respond to them, but instead asked another question. What are those children's parents? So it's an open question, but also social contents not specifically targeted on donation procedures. So now, as long as that we understand the data, so so we annotated around 100 conversations with these fixed number of intents. So we know basically the backbone of how these conversations unfold. Now we can actually build a conversational system using these kind of semantic scaffolds to require that so that we can reduce the required training data. So for a classical conversational system, so this is a little bit more computational, but I'll try to explain it in a very plain way. A modular dialogue system framework is usually used to build task-oriented conversational systems. So first, you wanted to, so a user would say something, tell me more about the organization. And then the first component called natural language understanding is gonna convert that into a semantic intent, which means it's a task inquiry, request for task information. And then once the computer knows that it's he needs more information, and then the next thing he's going to do is going to trying to look at the history to see what are the previous history so far. So for example, we don't put everything in the history memory of the system. We only put the most important thing that we wanted to remember across history. For example, how much did the user agree to donate? So currently there's no donation. So we have to respond to the user's current question in order to improve the donation score. Then finally, so we have this dialogue planning policy that we know that people ask a question about the task, and we still don't have donation given the dialogue state history tracker. So that the system at this moment should perform a movement called provide information to satisfy the inquiry. And then we're gonna finally, given that the system is gonna do this particular semantic intent, we're gonna convert that into a natural language. Specifically, for example, the children, helping millions of Syrian children who are facing the daily threat of violence. So there are 4 components in total. And every component, you can think about it as a machine learning task. So for example, this kind of intents into natural language is also a sequence to sequence task. Once you have 1,000 or more than 1,000 training data, you can train a model to convert this. So modular dialogue framework, of course, have some drawbacks. For example, you updated the first module, then you will have some miscalibration of the data format in the input and output. So you have to definitely update all the following modules. And it really requires heavy experts involvement in designing the annotation scheme, training individual modules. You wanted to also hire a lot of normal annotators to annotate every conversation. So there are a lot of human efforts in it. So that's why in recent several years, End2End Framework is pretty popular. So basically, you just say something, it's a natural language utterance. You want to feed it into an encoder decoder model. So you can also call it a sequence to seek model. a neural network model. You have millions layers, and then you will get a system utterance. So currently, like these GPT-2 model or GPT-3 models are examples. But of course, these models also have their drawbacks. It's very difficult to perform error analysis. So if you find that if you given a user utterance, the response of the system is not accurate, you don't know how to improve it. You don't know which part is wrong. Is it the model didn't understand the user, or is it because the generation has an error? So what you can do is just tune in your millions of parameters, which is not very practical. Another thing is these kind of model, of course, it doesn't use any of the labels required, but it's also very inefficient of using the data. So it requires a lot of information to train. So for a very simple task request task, for example, request bus information, it requires thousands of dialogues to train. So it's not really friendly to low resource settings such as Persuasion, because it's we only have 1,000 dialogues, but it's really complex in terms of semantic space. So what we propose is trying to combine the modular and end-to-end models together into a what we call modular supervised neural network. So everybody has, so we still have an encoder-decoder framework. So we have one encoder to encode the user's utterance. But during the decoding, we're not skipping like the intermediate steps. So we're gonna have 4 decoders. One is decoding the understanding of the user's utterance. Then we're decoding the dialogue states, which is the history we remember. And then we also are decoding what is the system gonna do, the system action, and finally decoding the natural language sentence of the system. So you can think the 4 decoders are sharing information through hidden states instead of symbolic outputs, which can cause error propagation. So here is a neural network. You can see, any type of neural network. So here we just use an LSTM as an example. So you have a previous history, BT -1. We don't have donations so far. And then we have a previous response of the system. Are you interested in charity? And then we have an utterance from the user. What do you have in mind? And then we're first gonna decode the understanding of the semantics of the user's utterance. So what do you have in mind is actually asking about task information. And then you go into history tracking. So far, we still don't have donation. And then what we're gonna do, so the planning of the system tells you that we should provide factual information to satisfy the task inquiry. And finally, we're gonna generate a natural sentence such as save the children, it's blah, blah, blah. So all the information is connected through hidden states. During the testing, you can decode multiple things, but of course, the user only gonna see the natural language sentence, but you can see all the intermediate results, which is gonna help you to debug your code. So for example, the understanding output was wrong. So you know, oh, this particular sentence is not didn't get fully comprehended. So what we're gonna do is we can collect more data in the training set that targeting on variants of the utterance of the user so that you can increase your data set in order to improve your NLU understanding. So if your planning was wrong, so basically we didn't have enough data to map such history into the next action, then we can create manually more data in order to buff the training set. So we can also look at, in terms of computational cost, it's really, you have something that you that is the output of your natural language understanding component. This is the hidden state called MT. For the next dialogue state tracking, you're just gonna condition the MT in order to generate ST. So it's really computationally, it's just a conditional generation process. And all the 4 modules are optimized jointly. So you can also think of it as multitask training process. So another advantage of this modular supervised model is you can also have partially labeled data, which means that, for example, you only have 100 data that are annotated with intents, but you have 900 data that is not annotated intent. What you can do is you're gonna update the data first with unannotated data, but you don't update NLU, DST, and DPL, you only update on NLG. And then when you have the annotation for the rest of 100 data, then you can update the for module. So it's for very flexible for industrial use. So now we are ready to actually train a dialogue system model to persuade people to donate to the charity. So we first are gonna pre-train the model with social conversational system. As we know, like these deep learning models would benefit a lot from pre-training from a huge number of data sets, but not specifically on this task, but nearby task. So here we're gonna pre-train it with social conversational system. So it knows how to do greetings and how to do like a thank you and so on. And then we're gonna fine tune it with conversational data that we didn't annotate. And then finally fine tune it on conversational data we annotate on semantics. So for example, we look at history so far is donation 0. And then previously the action of the system is provide fact. Previous system says save the children, provide help to children. And the user is asked, tell me more about the organization at the moment. So the user intent is ask for more information, which is task inquiry. We don't have donations so far. What we should do is provide more facts. And then we're gonna provide more facts through natural language. So this is how the training data is fed in. So the advantage of our model is it's easy to update. It requires less expert involvement. It is easy to perform error analysis because you have intermediate semantic output that can be understood by human, so that you can fix the model by collecting very targeted data. And of course, it can handle complex tasks with very less data. So in terms of how many training dialogues you need and how many annotation you need for the data set is really a balance. So if you are a big company, you have millions of data, for example, for customer service, then you need very few of annotation, then you can get a pretty good model. If you're a startup, you only have like 200 data points of your dialogue, then we would suggest you just annotate them so that you would get a better sort of a backbone for supervision. So it's really a trade-off. Of course, in a lot of sense, we would think collecting data is really difficult because you wanted to have all these users. In order to have all these users, you should be able to have a lot of like your emphasis in collecting them, cleaning the data. So we would suggest you have around 1,000 dialogues and then start to annotate at least 20% of them in order to build pretty good conversational systems. So now it's a time to evaluate how good our persuasive systems are. So we have the same mechanical Turk setting. So except that the persuader is a chatbot. And we do tell people, which is the persuadee, which is a human mechanical Turk, that you're gonna talk to a chatbot, but all the other things are the same. So the baseline is a model that trained with end-to-end model. You can think of it as a GPT-2 model that was fine-tuned on 1,000 dialogues that we collected. So here the percentage is how many percentage of people donated. So we ran the study around 100 per condition. So some people may drop out. Some people may have some weird stuff that we excluded in the conversation. So it's never like a fixed number. So it's around like 32 people donated in the baseline. Our MOS model that have 300 dialogues with labels, we have 5% increase, while the human performance, basically doing the data collection, around 54% of them actually donated. So we can see there is a still huge gap of our system performance to the human performance, around 17%. So one of the things that we notice that is because our model is a generation model, which means that it's not using a pre-written template, it can generate anything that is in natural language form. So if we got a response, a request from the user, such as, can I get a refund on my donation that we haven't seen in the training corpus? We can very likely respond saying, yes, of course, everyone can get a refund, but that's not true. You cannot get a refund. The reason that the chatbot generates, yes, of course, you can get a refund is when asked a yes, no question, the likelihood of giving a yes is much higher than a no in the training corpus. So this can really go around. If you're using our chatbot for customer service and so on, you're going to bankrupt the entire company or get the company a really bad reputation. So we need a safety net really for deploying such generation-based conversational chatbots. So here we have a response ranker, which means that, for example, you can say anything to progress in the conversation, but there are certain branches that we cannot move forward, certain intents that the system cannot express. So we want to make sure that we tell the system this is a dangerous path and don't go forward. We're going to do that through imitation learning. So for example, a user says, how much would you donate yourself? So this is very commonly seen. The persuadee would ask the persuader, would you donate? So this particular sentence in terms of intent is a request for donation amount. Semantic slots is something we wanted to remember throughout the conversation, which here is specifically donation amount. Our model can decode multiple times in order to generate different candidates. For example, we can say, I will donate $1. So provide donation amount, $1. Thanks, thanking, I don't have money, refuse to donate, donation amount equals to 0. So at this moment, basically you can choose which one to reply to the user. So we're gonna hire a human to pick which is the best response given the conversational history. And then we ask this particular expert who was trained by conversational series and persuasive strategy to help us to demonstrate what's the best selection for given context. And then we're going to train the chatbots to imitate the human selection in the generation in order to optimize the donation. So if we were using the imitation ranker, we're going to do the same evaluation process, and we're able to increase almost 10% from the original mods. So here is really making sure knowing which semantic intent would follow certain conversational structure would largely improve the conversational results. So here, so any questions so far on the imitation ranker? Yes.
Hi. Really great. So I just have one question regarding the previous slides, in particular the LSTM model that you mentioned.
Satya, we can't hear you.
Sorry. Am I audible? Is it better? Okay. Sorry about that. Really great talk. So yeah, I just wanted to ask you one question about the LSTM that you mentioned. So, and as you also mentioned that you use a pre-trained GPT-2 architecture. So as I understand, so GPT-2 is based on like causal language modeling, which takes only the left context during the text processing. So I was wondering, like, is there any benefit of including the right context as well? So it's something like a bi-directional encoding scheme. Yeah. That's a good
question. So we're using a transformer model so that it's comparable to these kind of GPT-2 things. So transformer model doesn't have left or right or left. So it's just one direction. So because conversation in a way we are doing is in real time, you don't really see the end of the dialogue. So you only see one direction. So you don't see the other direction. So usually in real-time system, we always just use one direction.
Right, okay, got it. Okay, thank you.
Okay. I have one more question.
Zhou, this is fascinating. Just a question, I think somewhat related to your safety net question. So I can imagine the dimensionality of this process, right, grows very quickly. So somewhere, if I'm not mistaken, you must implement some kind of dimensionality reduction process, right? So say so is there any sort of meaningful way to talk about how robust the output will be to say like to difference in your dimension reduction strategy? Say like more plainly, I say, would a small change in the dimension reduction strategy generate a very big change in the response?
Definitely. So in terms of modeling, so you can think about these kind of transformer or all these kind of different models that has different layers and so on. So each layers are getting more information over time. You can think of it as a dimension compression process. Yeah. So usually right now in the common practice is the bigger the model, the better the performance is. So basically multiple layers, more compressions over time is definitely better. But on the other side is this model is requiring a lot of computational costs, yeah. Especially for conversational data. We need real-time response. So the inference time, we also wanted to be a little bit faster. So you can think about these kind of GPT-3 model is not going to be able to do real-time inference in real time. So you always see this lag when you're doing the request. So we are doing a lot of work in terms of efficiency. There is also definitely people working on distilling these big transformer models into smaller models, but still pertain comparable results.
So is non-convergence a big problem in this kind of system?
Yeah, the neural model is all gradient descent based. It's always local optimal. It's never global optimal.
Thank you.
Okay, cool. So let's take a little bit of time to look at some error analysis. So this is a conversation we collected through using our chatbot interacting with human users. So we would say, the chatbot say, have you ever heard of a charity called Save the Children? You say, no, I haven't. What is it about? And the chatbot says, it's an international organization that promotes children's rights, provides relief and support children in developing countries. Does it sound like something you get behind? And then so particularly, if you look at the decoded semantics, it's a request to donate. It's using a strategy called credibility. So it's providing credible information about the charity. And then the user say, no, thank you. I'm already making a difference in many children's lives. So it's a negative reaction towards this credibility strategy. And then the system then generates another request to donate. Save Children was founded in 1919, and the charity is highly rated on many positive awards. Would you support them? So this is another strategy of credibility appeal, but it's definitely not really very useful because people are really reacting negative towards it. So ideally, if we ask the expert to look at it, the correct way of doing it is trying to diversify your strategy. Saying something like, that's great, it sounds like it's an issue you really care about, then why not put some of the effort into a charity that's doing really great work like Save the Children. So here we really look at that we wanted to model what's the user's reaction towards a certain strategy, given the context, and trying to optimize towards what, trying to imitate how successful persuaders trajectory of React, selecting different conversational strategies to optimize your donation outcome. So this is one of our paper in modeling this. So I'm just going to touch a little bit of on this due to the interest of time. So we identified several of the strategies throughout the corpus we collected from human conversations. So credibility appeal, the charity is highly rated, blah, blah, blah. Emotional appeal, millions of children are dying. Logical appeal, if you do this, what's gonna happen? Self-modeling, which is what we've seen before, is if you donate, I will match your donation too. Personal story, I did something before that helped the other children. Donation information, so basically give specific instruction. For example, your donation will be directly deducted from your task payment. Foot in the door, which is saying something small at first, even 5 cents would help a lot, and later ask, you're already making a difference by donating. Why don't you increase your donation a little bit further? Things like that. So we're gonna annotate the conversation and strategies of the user and look at whether the reaction of the other party is positive or negative, and trying to model the sequence. And then we're annotating around a couple hundred dialogues that are successful in donation. We wanted to learn from the good ones, not the bad ones. And then luckily you can simply add an extra decoder in your modeling, which is we call it strategy, dialogue strategy planning. So dialogue policy planning defines what semantic intent of the system should be. But dialogue strategy planning also determines what strategy the system should use in order to generate the final natural language response. So of course, we're also going to add what strategy has been used before in the dialogue history so that we don't repeat ourselves or do things that is out of ordering. But purely just incorporating dialogue history is not enough. We wanted also to learn if there is common structural strategy traces that we can learn from successful conversations. So here, I'm just going to tell briefly. So we're going to learn from a couple hundred dialogues that we annotated and trying to model what is the common structure they share. And then we can incorporate this common strategy inside of our model in order to direct this conversational agents to select correct strategies throughout the history. So we're going to skip the modeling. So after we incorporate the strategy, we're going to be able to increase around 4% in the evaluation. And we're still like 3% below human performance. But luckily, we do see the improvement over adding, for example, from injecting semantics, we get 5%. By imitating human, improving safety, we get 10%. By tracking strategy, we get 4%. But today we're not able to cover the final task, which is another paper from Kai. If we do personality adaptation, we can actually reach around 60% of persuasion, which is actually higher than average human ticker. So here I can share some of the important, interesting things to you. For example, the model learns that this person actually is more likely, is more, for example, what we call it, based on the Big Five modeling, the survey they answered, we know this is a neurotic person. So we're going to provide more factual information to their questions. So actually, neurotic people, if we can answer their factual question correctly, they're more likely to donate to the charity. So that they're not really not caring people. They're actually people who want more certainty about facts. So if you do these kind of adaptation, also we do find that usually social content, like do you have kids yourself and things like that, works fairly well with people who are more sociable, more agreeable. Okay, so in the end, I would just want to give some broad concept of what conversational agents look like. So you wanted to understand what people say in various languages. Here we're just using English. You wanted to plan what are the best trajectory for the system to utilize strategy. And finally, you want to generate language that is consistent, coherent, and safe. Finally, you also can incorporate text information, audio information, or visual information, even touch information, so that the chatbots or robots in the future can be more situated. So I know whether you're happy or not, are you excited, or are you confused? Based on these information, I can plan my conversation better. Finally, integrating common sense, knowing some of the rituals, some of the cultural policies could also help you to select strategies better. Finally, we're taking to human factors, such as like your Big Five, histories, expertise, and so on, so you can actually manage it better. We're publishing all these kind of different fields, such as machine learning, HCI, robotics. We're also looking at security in terms of deploying these machine learning based models in reality. One of the things I wanted to also point out is about protecting vulnerable populations. So we had an interesting DARPA project, which is we're going to build a chatbot that is helping people screen scam calls. So for example, it's a scammer, whether it's a human or whether it's a chatbot. So if you ask us, like, can I have your credit card number to start the refund process, we're gonna like sort of have a defensive strategy and then automate information already in your account. So we can like sort of trying to identify whether it's a scammer. So you can think about automatic voice responder, which is a chatbot. And then we can even request information from the scammer in order to identify where they are in terms of location or cell phone number for the police to catch them. We're also doing robotics in terms of recently we're doing a real estate agents that provides information about house information. So you don't have to have a real estate agent. You can have this kind of virtual agents and help you to walk through the rooms, give you information, and even persuade you to buy the house. Finally, I also wanted to talk about this ethical consideration, which a lot of people may have this kind of idea. If this kind of persuasive system was adopted by a villain, so for example, illicit donation for a charity. So it's actually, if it's not for a charity, then basically it's a scammer. So they're collecting the money for their own usage. So this is really a huge ethical concern. What if this technology was adopted by other people? So first of all, there are a lot of things we can do to help in order to prevent such thing happens. But the first thing is we need to educate people how good our chatbots can do. So for example, we conducted a study, which we was very surprised to find. So we have this kind of A/B study. So we tell people this is a bot, specifically giving them an icon and also giving them a parenthesis, it's a bot. And we do find that after interacting with the bot, after the conversation, we use a survey, say, do you think your partner is a bot or a human? And tell us why. And then in this very clear display, still 36% of people think the bot is human. And they give various like responses such as, oh, because it's very caring, because I don't think he has, because I think he understands me. So a lot of people would actually, mechanical Turkers would think that the bot is maybe played by a human behind it, not really a real bot. So unfortunately, this cases, a lot of time, especially mechanical Turkers, they may not have technical background. They're normal everyday people. They haven't been talking to chatbots that much. They may have Amazon Alexa, but Alexa is really limited into commands. But our chatbot is much more elaborative. It can use strategies and so on. So it's really dangerous for these people to encounter these chatbots if fall into a wrong hand. Only California state law requires chatbot to identify themselves, 2019, for specific tasks, such as commercial and political contents. And this is only restricted in California, not in other states or in other countries. And the unfortunate thing is, even you telling people this is about, still 36% of people don't believe you. So what we can do is definitely trying to deploy these bots so that you can actually talk to them and teach you some strategies to identify whether they are bots or not. By, for example, asking something out of domain. So you can see if the bot can reply or not. If it's a bot, most likely he will reply something very absurd. So here we're just doing a baby step. For example, we have another paper just about to release on how to test if your chatbot is identity safe, which means people may use various ways to ask whether you're a chatbot or a human, but the bot needs to identify that intent correctly and being able to respond with a responsible answer. Okay, I think that's everything I want to cover. We're a little bit out of time. Any questions? You see some in the chats, right? Do we have it? How well do the algorithm deal with interruptions? So that's a good question, because right now, all the experiments on the persuasive conversational systems are typing-based conversational agents. So you're typing. So you have these kind of really long utterances. So if in speech-to-speech, usually the utterances are shorter. So the interruptions happen in real time, for sure. So right now we are doing very sort of like a fundamental thing. So is if the pause is longer than 1 second, we're going to cut it off. So the system is going to interrupt. So this is a constant pain in conversational agents that interruption happens. Any more questions?
I had one last question. So by introducing these kind of defense mechanisms or certain kinds of, so as you mentioned, like educating people how to, or I guess letting them know certain strategies to help identify bots and so forth. I mean, in general, I was thinking like, is there a concern there that this would pollute future training instances, or for example, so like the understanding of such strategies can then seep into natural language, which because as OpenAI or other big companies periodically come up with new iterations of their models, and they train on like more internet data. So is there a concern there that this would eventually lead to like pollution in the training set?
I think it's really definitely there is. You have all these strategies, and of course that people are going to take into these kind of adversarial examples into consideration in the future to train a model that is more robust to these adversarial samples. This is going to happen.
Right.
So that, but this is also improves your conversational systems quality as well.
Right. Okay. Thank you.
Okay, I see more questions.
If there are no more questions, I would like to thank Zhou.
Thanks.
For giving the seminar. Sorry, I came a minute late, so I couldn't introduce me before. So that was pretty exciting. It's nice to have this diversity in our speaker series, because normally we are very heavily econ speaker, relying on econ speakers, but I really love the intersection between using sort of experimental methods and AI. So that I think, yeah, I guess everyone feels like that this is pretty exciting research. So again, thank you for taking the time to joining us. Our next webinar will be in 2 weeks. It will be on